Hello.
Hello.
You can hear me, yeah?
I can. Can you hear me?
Cool. Yes. Yes.
Yay.
So, thanks everyone for joining the meeting. I think we have a few more folks will join. I can start sharing my screen. See. And I see Mike as well, which is cool. Welcome, Mike. Thanks for joining. So you can see my screen, yeah? Agenda. Let me put the link to agenda to chat. So maybe we can slowly start while others join. So welcome everyone for our second meeting for the Special Interest Group Software Supply Chain. Last week, 2 weeks ago, we had the kickoff meeting for our SIG discussing about how we can work on contributing to overall efforts to improve security posture of open source projects from CI/CD perspective. And that was mainly brainstorming discussion around what we can do and how we can, work within the SIG. And we had some slides to kick off discussion during that meeting. So if you are wondering what we discussed, you can take a look at the meeting presentation that is linked on the meeting minutes of the previous meeting, and we took some notes on the slides directly. And if you have, any additional comments or ideas, you can bring them to, agenda for upcoming meetings. And I see quite few new faces, and that is the other thing we did during the previous meeting. We simply introduced ourselves and what we expected to achieve within the SIG or what we want to do with the SIG. Maybe if I can, call out some of you who joined first time today to introduce yourselves. I hope that's okay. So in the Zoom attendance participants list, I see Billy Lynch as the first person to introduce himself. Billy?
Hi, how's it going? Yeah, I'm Billy. I currently work at Google as part of the Tecton project, and I've been focused on sort of secure supply chain efforts on the Google side, particularly for open source with Tecton. So happy to get involved, happy to discuss more, and yeah, happy to be here.
Thanks for joining. Billy, and then I see David Espejo. Maybe you are muted, David.
Yeah, sorry.
Yeah.
Yeah, everyone, David Espejo here. I work for VMware as an open source community manager. In this role, I support a couple of projects, the Cartographer project and also Paquetto build packs, mostly with anything that is non-code in terms of community engagement. So my goal being part of this SIG is to keep learning around the whole supply chain security field and help wherever I can. Mm-hmm.
Welcome, David.
Thank you.
And I see Enric.
Hi everyone, I'm Enric. I'm working as an IT architect in CaixaBank, a Spanish company, a Spanish bank, and in a common services team. and I'm here to learn about supply chain security, and perhaps I can share my opinions to improve.
Yeah, that would be great. Thanks, Enric. And I see Maur next.
Hello to everyone. My name is Maur Couriel. I'm a director of product management focusing on cloud native solutions. As the rest of the team, the rest of the people said, I'm here to get more knowledgeable about supply chain security, to help me build better products to align with my customers' requests.
Welcome, Maur. And then we have our invited speaker, Mike Lieberman. Hi, Mike.
Hi, I'm Mike Lieberman. I do supply chain security over at Citi, and I'm also one of the leads on the supply chain security working group over at the CNCF. And also, we have recently contributed a sort of a system that is sort of a implementation of the CNCF's reference architecture on what we're calling the Secure Software Factory, which I'll be giving a demo in a little bit. Yep.
Thanks, Mike, and thanks again for joining us today.
No problem.
And I see Timothy Miller as well.
Hey everybody, I'm Tim Miller. Mike and I both work at Citigroup together. So Mike's been handling kind of the external focus, and I've been handling the internal stuff at Citibank. But happy to be here.
Welcome, Tim. So I hope I haven't missed anyone. If I missed one of you, Moise, maybe I just noticed.
Yeah, I'm Moise Kameni. I'm from Canada, live in Canada. I'm a CGF ambassador, so I just found the link on the Slack. So I'm happy to be here to participate too. So thank you.
Welcome, Moise. So I think, yeah,
I'm gonna, because I'm on my phone, my cell phone, so I'm gonna switch to the computer now. So I'm gonna disconnect and reconnect.
okay, yeah, we will have a few logistic discussions before we start with Mike's presentation, so you will catch us. So thanks everyone for being here, and thanks for introducing yourselves. So we have a very limited agenda today because we want to spend most of the meeting time for the presentation from Mike, as well as a follow-up conversation, because like the Secure Software Factory looks pretty awesome. I've been playing with it for the last couple of weeks, so it would be great to spend the remainder of meeting for any questions, comments, or ideas about the Secure Software Factory, and perhaps the possibility of using Secure Software Factory as one of the projects as part of the POC we intend to bring up under this SIG. So that's why our meeting agenda is pretty light. So we start with the first topic, action item review. We don't have any action item from previous meetings, so we can move to the next one. So as you know, I think North America made the switch to summertime 2 weeks ago, I believe. So now the regular meeting time is 1 hour later for the participants from North America. And for European participants, we are meeting at the usual time, but Europe is moving to summertime this weekend, I believe. So because of that, we will change the meeting time to 3 p.m. UTC starting from next meeting on April 14th, which will bring the meeting times to their usual times for everybody, like for, I think, 8 a.m. for West Coast US and 5 p.m. for Europe and vice versa. But you can always check your time on various websites to see you join at the right time. Also, if you want to, get the meeting invites on your calendar, we will send the, recurring meeting invites to the 6 mail list. So if you subscribe to mail list, you will be able to have that in your calendar. you don't want to do that, you can check the CDF public calendar, which is linked on the agenda, and you can see these 6 meetings, as well as the meetings the CDF committee has, such as other 6 and technical oversight committee, to make sure you join at the right time after this summertime change happens. So that is a reminder. And the other reminder is about the presentations. As we discussed during the previous meeting, we will invite contributors from other communities to come and join to our SIG to present the projects, initiatives they have there within their communities. And the first one of such presentations will be given by Mike today. But we have few more presentations scheduled for upcoming meetings. And those presentations, what is the topic, who is presenting, date and time, they are listed on our presentations document, which is linked on the meeting agenda document. So this week we'll have the presentation from Mike, and during our next meeting, which will happen on 14th of April, we will have Priya visiting us, talking about Tecton CD chains. 28th of April, we will have Thomas Schwartz from Dynatrace joining us, talking about CNCF, tag up delivery, and Potato Head. And then James Rawlings will join us May 12th to talk about Cartographer. And we will probably add more, presentations to upcoming meetings. And this means that if you have something to present, it doesn't have to be a project. It could be a topic. You can simply, list your presentation on this document and just say, well, hey, I want to talk about this topic. Can I, get 30 minutes of the meeting time? And then we will make sure you get 30 minutes in the upcoming meeting for that topic. So any questions for these 2 topics, meeting time and upcoming presentations? Okay. Then I stop talking because Mike is with us. So Mike, I stop sharing as well, and you can go whenever you are ready.
All right, cool. Give me 1 second here. So first, I'm just gonna share something real quick, and then I'll switch over to some diagrams to kind of walk through everything. So you can see my VS Code. Yes. Is it big enough for folks? Can everybody see?
Yes.
Okay, cool. Just wanted to make sure. Okay. So just because it's going to take a couple of minutes. So right now I don't have a mini cube up. So I'm going to be in the background here, just setting up a mini cube with everything on it. And while that's getting set up, I'm going to switch over to what the Secure Software Factory is. Give me 1 second here. All right. So the Secure Software Factory, first and foremost, is a reference architecture that was written up by the CNCF, which I was one of the leads on. And so the Secure Software Factory, and it will be published in the next couple of weeks. It's just currently going through CNCF TOC approval. But to kind of give you just sort of a highlight of what it is it's a reference architecture that's intended to help with building of software artifacts securely, right? In a way that we can also begin to bring, some reasonability around our supply chain. And the core of it is mostly, let me see if I can find this. So the core of the purpose of the Secure Software Factory is around 3 sort of critical concerns. One is provenance verification. The other is trustworthiness. And then the third is sort of recursively doing that for all of your dependencies. And so the key thing that has sort of been missing from a lot of the stuff in the sort of CI/CD space has been whoops. A lot of the stuff in the CI/CD space has been around sort of provenance, right? Yes, we're doing security scans. Yes, we're doing, linting and security linting and SAST and DAST and all those sorts of things. The problem that has come up time and again is, how do I know that I ran the scan on the right artifact? How do I know that somebody didn't replace that artifact? How do I know that what I built was actually the source code I thought I was building? How do I know that something didn't come in the middle? How do I know that a library, that I thought I was building against was actually the one that was used? So that's really the core of what we're trying to do here. So give me 1 second to just make sure I get the other stuff here. All right. So let me go up here. So these are some diagrams. Is it readable for everybody? Do I need to make anything larger? All right, cool. So the secure software factory sort of exists in the same space that you would imagine a lot of other sort of CI/CD and build tools would live in, right? So you have your developer gets feedback from, CI/CD, your developer pushes code to source code control, and then, your CI/CD system, in this case, we're calling it the secure software factory, pulls code from source code control, and then builds it and does a bunch of, does whatever you need it to do, and then pushes those artifacts to artifact storage. It also pulls dependencies it needs from artifact storage. And then, as you can probably imagine, in production, you want to sort of validate that, hey, I want to validate that the signatures and attestations that are coming out of the secure software factory, right, that I'm only running artifacts in production that have those signatures and attestations. Quickly here, this is just sort of a level down, deeper, more zoomed in look there. But if I now kind of go in here, you can see, and let me make this larger. There's a couple of things here that are, all right, let me just move a couple of things out of the way. Okay. So I know this is sort of a hard to read diagram, but this is sort of the idea here, is trying to sort of show what all the different pieces are and how they sort of all interact. And so this is very, very high level overview, and I'll kind of talk to sort of what tools we're using in sort of one of the implementations called SSF. So ideally, right in the middle here is you have your build environments, right? So these are the actual build containers that are running your builds. And so how do we make sure that, they're running the right things, that they're running the right things in the right order, that things are not, things are not being skipped, and that, you're not trying to pull stuff from, you're not trying to pull things from inappropriate places, right? So how does it all work? Well, I'll just kind of go around sort of clockwise here from left to right there. So the core bit of it is, we have a pipeline observer. So in this case,
Michael?
It's yes.
Could you please zoom in for those kinds of folks like me, that we are getting old by the seconds?
Oh yeah, no problem.
And I'm not seeing very well.
Yeah, no problem. Is this better?
Yes, thank you very much.
Sure, and I'll zoom out and move over to some of the other places when we need to get there. Okay, cool. So, so the pipeline observer in this case is something like Tecton chains. So, right, so Tecton is running the builds, but you need something to actually record what is happening in those builds. What is Tecton reporting back out, right? One of the big things that has kind of come out there, right, is we don't want builds themselves, as in like what's happening inside of a build, to self-report, because a build, because it's arbitrary code written by who knows, right? Like they can misreport a lot of information. So that's why you need something like Tecton chains. And so with that, right, Tecton chains needs to validate, the identities of what is actually running those builds. And that's where the workload attester and node attesters come into play. And this is sort of, for folks who are familiar with it, this is where sort of Spiffy Spire comes into play, where, when I spin up a build container, we want to validate that both, hey, when I'm spinning up this Tecton build, is it running on a Kubernetes node that I own, right? How do I know that it's not running on some, compromised node? Well, you can use a node attester for that. And the same thing goes with workloads, right? How do I know that when I'm spinning up the container that I'm actually spinning up a container that, says, hey, look, this is where, the code lives, or, here's the parameters to the build. Well, that's where the workload attester comes in, so that you can actually validate, hey, am I actually pulling the code from the right place? Those sorts of things. Because then if eventually, if the workload, when the container first gets spun up, it sort of generates almost like a hash of all of that metadata regarding the spinning up of the container. And if that hash does not match the hash at the end, well, Tecton will not sign it, right? Because they'll say, wait a second, these hashes don't match. Something must have changed in the middle where, hey, I told it to pick up code from here, but it's reporting to me that it picked up code from somewhere else. And it stores all of this metadata that's coming out of the build in metadata storage. So next up, right, is then, okay, well, that's sort of recording the build and all that sort of stuff. So what are we doing regarding making sure that only approved builds are running? Well, that's where policy sort of management and the emission controller comes into play. So not only do we need an emission controller for production workloads to make sure that only things that are signed by, your secure software factory are allowed in production, but you also need to do the same thing for your build environments themselves, right? You need to make sure, hey, is the build image that I'm using signed by our key, or signed by, a key that we trust, or an identity that we trust? And so this is, another thing that comes into play, right? When I'm running Tecton, how do I know that I'm running actual Tecton? How do I know somebody hasn't replaced the Tecton images with something else, right? I want to make sure that the Tecton images that I'm using are signed by, the Tecton maintainers, if I trust them. And so this is kind of where a lot of that sort of stuff comes in. Now, finally, right, one of the things that the other piece of the puzzle is runtime visibility. So you also need to be able to say, how can I look at what's happening in a build so that I can detect anomalous behavior, right? So this is stuff like, hey, I'm running a build, even though I didn't give that build network access, right? It's just running the compilation piece, right? And it has all of its dependencies already. It should not have network access. But the build itself is still reporting, hey, it's trying to reach out to the internet, to malware.com or whatever, right? Oh, okay, well, I want to know that, right? So not only do I want to lock down the build, but I still want to detect anomalous behavior, like it's trying to go out and do something it's not supposed to. Hey, this is in one of the demos we gave, Tim and I had given at Supply Chain Security Con last year at KubeCon, was we showed off like, a compiler that had been hacked that injects a binary into memory and then executes that binary that overwrites whatever you built. So you think you built something and it overwrites either the source code or the actual output binary. And runtime visibility can catch that by sort of saying, whoa, hold on, I'm expecting a compilation to sort of look like this. And it's going out, writing stuff into memory and then executing that stuff from memory. That's weird. You shouldn't be doing that. So that is sort of a level down view. And then this is sort of generally what a pipeline actually looks like. So, this sort of looks like your average pipeline, but where you're sort of fetching some code and some dependencies, you're linting it or whatever in your pre-build tasks and so on. You're building the artifact. You're building the artifact, then you're pushing out those artifacts. I should say, then you're scanning those artifacts or whatever, and then you're publishing, let's say, the artifact at the end. And obviously, this is just this is not what happens all the time. You can have stuff that happens after publishing or whatever, but just to keep it sort of simple here. And so the key pieces here is just, once again, the pipeline observer is recording all of this information and pushing the attestations and signatures to metadata storage. So this is stuff like Recore. If you're familiar with SIG store, this could also be inside of OCI itself. And so that's really, and so all of these, and then the other thing that's probably worthwhile here to sort of is some of these tasks themselves can also push their own attestations to metadata storage, right? So these might be things like, hey, this is some sort of SAS scan, that SAS scan ran, and then it sort of says, hey, I'm going to sign off on that scan with, my identity. And also pushes it to metadata storage. So at the end, hey, does this have an approved, SAST or DAS scan? All right. And then here's sort of generally how SSF, the tool that we've built, that sort of implements all of those patterns begins to work. So one of the things here is we're using a configuration language called Q that allows us to, when, actually, let me take a step back. If I just actually maybe go down to this one first. So, right, we're using Tecton chains, we're using Tecton pipelines, we're using Kyverno as an admission controller. And then we have a couple other resources that we're also sort of building out there. And the idea here is SSF tooling, right, which is using what's referred to as Q, which is a language that helps us sort of build the configuration, is sort of generating the actual YAML configuration for us, but allows us to sort of tie Tecton pipelines and chains definitions to other components in there as well, like Kyverno policies. So instead of saying, hey, Tecton chains, here's the key you should be looking at, and then having to write up a separate policy that says, hey, Kyverno, now look at this key, we have one configuration file in Q that says, okay, now generate me a Kyverno policy and a Tecton chains configuration that points to this key, right? So we can have it all in one place. So if the key ever changes, it's just one thing that we can kind of push out there. Because one of the big things, right, is as as our sort of CI/CD setup becomes more and more complicated, you want to kind of still have all of that configuration live as much as possible in one place, have stuff like inheritance and sorry, I should say more like composition, where, one configuration file can sort of generate everything we need. And so if I go back up here, what that allows us to do is say, hey, we can generate configuration that is secure, right? That's where this SSF defaults come in to play. Then you can say, well, individual organizations might have specific things they want to have, right? Maybe they want to have naming constraints. Maybe they want to have, maybe they want to have like a name policy. Maybe they want to have, hey, we're only a Java shop, right? So we only allow Java builds. You can sort of constrain it at the Q level that says, okay, great. If somebody tries to build something that isn't Java, sorry, it won't work. And the same thing goes with stuff like individual teams maybe have their own naming policy. Maybe they have specific versions of tools that they support, and so on. And then the same thing goes even to individual projects, where an individual project maybe has specific constraints that other things, upstream might not have. And so all of these things combined allow us to sort of define these high-level interfaces that, will allow us to sort of, it's almost the same amount of effort to manage 5 or 6 pipelines, right? 5 or 6 projects within this system as it does 5 or 6,000, right? Because, hey, as long as we have all of these things sort of defined, we can sort of do it that, we can sort of build that out. And then what it also allows us to do is sort of implement security policy and infrastructure policy as part of it as well. So, hey, security policy maybe says you must have a SAS scan as part of your build. Great. If you try to write one that doesn't match that, the configuration, quote unquote, won't compile, right? It's a little different, not actual compilation, but same difference. And so it won't, it won't actually deploy. And then we could also validate it as well against, eventually against stuff like Kyverno. And so at runtime, it'll also validate it, but at deploy time, it will also do that same sort of validation. Cool. So let me stop sharing. So before I go into more of a hands-on demo of hands-on keyboard demo, any questions about anything I showed off so far?
I have one question. So say we want to do this, like the same thing with, like some other tool. Say we want to use, like Jenkins X and not use, like Tecton. How hard would it be to implement that? So, like Jenkins X uses, like Tecton, but we don't use chains. So that's one, like project that we want to add, like very soon. And like maybe even build, like some sort of a controller that does, like similar thing as chains, but which is, like specific to say, like the pipeline stuff that, like Jenkins X has. If we want to do that and we want to, like push it, like upstream, will that help, or how hard is that? Just curious.
Sure. So the Secure Software Factory reference architecture. So most of those diagrams at the top there, yeah, use whatever you see fit that sort of matches that general flow. And once again, I didn't go too deep into the actual reference architecture itself, which will be published in the next couple of weeks. But let me actually just send the link. You should have read access to it. You just won't be able to actually modify it because it's been it's closed here. But the link that I just posted in chat, and if somebody can add to the agenda there, that is the Secure Software Factory reference architecture. Other than some typos or whatever, more or less should be what is about to be published. But the thing there, that sort of describes in sort of detail, and it literally does not talk about what tools or anything, right? It just says you should have a tool that does that performs this sort of action. And so if Jenkins X and whatever else can hit that, great. As far as SSF, our reference implementation here, or what we've built at City and contributed to OpenSSF. So SSF right now supports chains and pipelines and Kyverno and whatever, but we are more than open to sort of supporting additional tools as well. Because once again, the other thing that's really nice about Q is Q allows us to sort of abstract a lot of that sort of stuff away. Obviously, there's going to be a lot of practical things where you might end up needing to redo a lot of things if you go and say, hey, yep, we're going to swap out Jenkins X with Tecton or Tecton with Jenkins X, or OPA, we're going to swap out Kyverno with OPA or some other tool, right? There's definitely going to be some concerns there, but as long as you've sort of defined that interface at top and you have the individual implementations underneath, yeah, I don't see why not, outside of just, the practical concerns of potentially supporting, if we were to say, hey, will SSF support Jenkins X, let's say. SSF, the code, right? It's just more of a, hey, if there's somebody who's going to manage it and maintain it, then sure.
Okay, sounds good. Thank you.
Any other questions about anything else I showed off before kind of switching over to a demo?
So I have one question. Yes, go ahead.
Sorry, you first.
Yeah, just to, because I got confused about this myself as well, and you repeated it a few times, Mike, already. So Secure Software Factory is the name of reference architecture, and SSF is the name of reference implementation. Yeah, so we refer things correctly.
Yeah. Yes.
Yes. Okay.
So yeah, and to be clear, a lot of this is just we originally were calling it the Secure Software Factory as well, and then that obviously led to confusion where people thought that the code was actually also written by the CNCF, and given that this got donated to OpenSSF, we want to make sure that it was a clear distinction. And then the other thing that had come up was because the secure software factory coming from CNCF was the reference architecture, and the has a very specific meaning. People were thinking, oh, this is the only secure software factory. And so we wanted to sort of separate it out. And because enough people were already calling the code SSF, we've just sort of said, hey, and the backronym is SSF, SSF is a secure factory. So like that's, we've kind of reworded it. If folks still are confused, we can always rename it, but yeah, sorry for the confusion.
No, I think we just came right when you were making these discussions and RFC was there. Like just in the middle of that conversation, we suddenly came up asking for your presentation. But yeah, SSF is, yeah, now it's better. Thanks.
So quickly, can I just validate an assumption here? Are you working on the presupposition that this is a way of securely delivering open source software, or are you looking at the general case of delivering all forms of software?
It's the general case for all forms of software. There's obviously going to be specific constraints that might hit closed source versus open source, but generally, this should be applicable across the board. The practices at least should be applicable across the board. And in fact, the way we've structured the code is such that if you're an open source group that has a specific policy, you can implement that specific policy in something like this. And then the same thing is if you're a closed source, you can implement that same sort of policy, right? Hey, we only pull artifacts from our approved artifact repository. Great. This sort of thing can support sort of keying, just saying, great, no builds are allowed to download from anywhere other than here, that kind of thing.
Okay, I would just expect to see another layer of permissions management in terms of being able to verify that you were able to access closed source components from other providers or teams or vendors, and manage all of that as well, which is over and above what you would do in the open source space.
No, so it's still the same sort of thing, right? Where you can validate based on attestation signatures, as well as sort of pinning to hashes as well. So as long as vendors are using sort of, right now we're supporting the SIG store model, but as long as vendors are signing their stuff with SIG store, right? And you say, great, I trust that identity, then those are things you can run in SSF.
Okay.
Cool. Let me switch over here to a bit of the demo. And I'm going to be switching back and forth a little bit with 1 second here. Okay, so just to kind of run through a little bit, and it might be a little hard for some folks to read, but don't worry about it too much, is I am sort of spun up a Minikube, installed SSF, which consists of Tecton chains, generated some keys, set up Keyverno and some example policies. And let me just show you what, and let me actually make sure, whoops, I clicked on, wait a second. Oh, yeah. So right now I'm running an example pipeline here. All right. Whoops. And sorry, let me just make this a little larger in case folks can't see. Okay, so this is sort of an example pipeline. It's running some stuff in there. And all of everything I'm about to show you here is stuff that is already in the code where you can follow along if you wanted to run the same sort of thing. So this is just sort of going out, building, and so on. And while that's doing that, let me just switch over to the dashboard so you can kind of maybe get a bit of a better look here. 1 second. There we go. All right. So just to kind of go through what is it doing, right? It's doing a normal sort of Tecton thing. It's cloning a repo. And once again, a lot of these, pipelines right now are very much simplified. In reality, you'd probably do a lot of you'd have a scanning step, you'd have all those sorts of things and whatnot. And so, here we have something, we're building an image, we're pushing it out. We're generating an SBOM for that image as well. And then, the image that gets pushed out is over here and whatever. And then we're going and deploying the image. Ideally, we probably wouldn't deploy it as part of the same pipeline. We'd have some approval steps, but just for the sake of the demo, that's some stuff we're doing there. And so just to kind of go back to the code here. All right. Okay, so I'm just going to fetch information about the image and the task run just so that we can go in and just to show you what's actually there, right? So the image, right, we're using a sort of free, what's it called? Registry here that expires after an hour. Don't worry about it too much, but the main thing is, hey, my image, it has an attestation, it has a signature. And so, Tecton, as you're aware, goes and signs those things. So if we want to go in and verify that, I can go and verify, was it signed by the signing secret that I have? Yes, cosign can verify that it has the right signature. And I can verify that I have the right attestation, right? And if I want to figure out what's in the attestation, right? Give me 1 second. Wait a second. Right. And whoops, and then type that into JQ. Right. And so here is the actual attestation that came out of it. So this is a salsa provenance statement. Sorry, it's an in toto. It's an in toto statement with salsa provenance predicate format inside. And, it has all this information about, what was the builder images that were used and so on and so forth. And then in addition to that, if, so that's all the stuff that's in there. We're also using some Tecton internal storage. Don't worry about that error. That's something from Go. But we can sort of validate that there's a signature in there, and we can also validate the same sort of payload from the attestation. And then this is now running inside of my environment. And just to kind of show you that something would not, if I did not, if I was using something that wasn't built by the thing, it would not run. I can show you that here, right? Where, hey, I'm trying to run this image, right? In, the theoretical production namespace here. And hey, the Kyverno says, well, hold on. You don't have the right attestations. And yeah, so any questions about anything I showed off here? So just as a kind of like a reminder with some of the stuff is that, you know, the way that sort of SSF is working, right, is we actually have Kyverno validating a bunch of different things. One is when running the build, we are validating that we're using valid Tecton images signed by Tecton keys, or we're using other sort of approved images signed by folks we trust. And so if somebody came in with a different type of builder and they didn't have the right sorts of keys, just wouldn't run. And then, you know, by going through all of that, we can start to sort of build provenance throughout that sort of process where, you know, we have at least some level of guarantees that we pulled code from the right spots, that if we pull down dependencies, that we pull down dependencies from the right spots, that, and then when, you know, we build it, hey, we think generally, hey, maybe this thing, you know, wasn't compromised or whatever. There's obviously a lot more work that needs to be done on that space as well. And then when we sort of build everything, we're now sort of saying, great, you know, I built this hash and I'm going to push all that information out to the OCI registry, or you push it out to Tecton's internal storage, or push it out to Recore or whatever. And then we can then sort of make decisions based on that, right? In production, you'd probably have something like a Google style binary authorization sort of setup. But, you know, for now, for the simple case, you can probably do something like Kyverno. And then obviously a lot more stuff is going to be built out over time. And if folks want to see the code real quick of what that looks like. So this is what the sample pipeline looks like. And this is Q. And I'm not going to get too deep into Q, but a lot of this stuff is actually pretty easy to convert from the YAML config to Q, but it allows us to easily parameterize stuff. It allows us to eventually begin to abstract a lot of things. So you can say, you know, a development team might say, here are my list of trusted keys, right? And you know, those trusted keys, if anything falls outside of that list of trusted keys, you know, it will not pull in those dependencies. And, you know, here's my signing key, and it will automatically pull in that signing key and do all that sort of stuff. And yeah, so that's really all I had for this sort of demo. There's some other demos that, you know, if folks were interested in the future that we can show off. You know, we can show off a bit more sort of end to end. We can show off stuff like, what if somebody does try to compromise, let's say, a build, how would this system sort of catch that sort of thing, you know, at different levels? Like, you know, if somebody tried to replace your source code, what would that look like? And how would this be able to sort of catch that sort of problem? And you know, what if you try to download a dependency, you know, a bad dependency, what does that look like?
I have a question. As I mentioned, like, I've been reading about the reference architecture and playing with SSF. And if I understood it correctly, I think you mentioned this, like, you have deploy pipeline there. And like, if we say, okay, deployment is the last thing we do as part of SSF implementation. So what is your thinking about like extending that a bit further to production? Is that, for example, sometimes some of the stuff you are running in production, may have vulnerabilities disclosed. Like, do you consider those things running in production as part of the supply chain, like concerns, or things are done once we deploy it there and it's someone else's problem?
No, I think it's still part of the same problem. I think the thing that Secure Software Factory was trying to solve was the build piece. There's still pieces around the production sort of binary authorization piece. So this is where stuff like, you know, and we can go on for a long time here about all the different things we might want to include as part of that authorization. But it's my opinion, at least, that the way that it should work is you generate all these attestations. They're all stored in some place that you can access. And a binary authorization sort of piece, which, to be clear, I don't think there's really many of them besides maybe Critis and Grapheus, that kind of thing. But I think that the way that things are moving is you say, okay, great. I have, let's say I have a scanning attestation. I have a build attestation. I have a linting attestation. I have all these different things. Maybe I have an attestation that the product manager approved or whatever. And I have all these attestations. Now you could code all of that as policy in something like Kyverno. The problem is you have a lot of those policies, things will start to get slow. And it also becomes difficult to sort of easily reason about. But if you have something like a binary authorization process, you go and you say, great, once a day, once a week, whatever, once an hour, doesn't matter. I go through, I scan all of those things. And maybe as part of that, I go and as part of the binary authorization is, hey, maybe I go back through the SBOM and say, are there any new vulnerabilities that have come up? If yes, I'm going to alert on it, right? Maybe I revoke access to QA or dev, let's say, but I don't, let's say, revoke access to production because we still want to keep things running, but we don't, let's say, allow new deployments in production until that sort of thing has been pushed out. But you know, I think the way that folks are starting to move is sort of this idea of, hey, based on you having all the right attestations, I'm going to create one new composite sort of attestation that includes, you know, essentially is the binary authorizer to say, hey, I checked everything and it looks good, and I'm going to stamp it for 1 week, 1 day, 1 month, whatever. And I think obviously a lot of that's going to be up to the individual organization or whatever that feels comfortable with. And then from there, you know, you might constantly be going back and validating like, hey, has it gone through if there's like a new heuristic scan, right? Great. Well, binary authorizer now says you need to go through that scan. And if you haven't, I'm not going to renew your binary authorization. And if you can now provide an attestation, whether that attestation is part of a new build, or if it's part of a new build, or if it's, let's say, you know, out of band scan, it doesn't, you know, the binary authorizer wouldn't necessarily care. And I think that's where folks would like to move. But there's still a lot of things that need to be built out there. And there's also still a lot of open questions even today. Like you asked, I don't want to go too deep down this rabbit hole, but if you ask somebody what should be included in an SBOM, you ask 12 different people, you'll get 12 different answers.
Yeah, that's exactly the reason, because like I'm not saying like all the things that happen on the left-hand side, closer developers or, you know, production environments are not important, but like more like majority of the focus is on that side, and the right side or production side is a bit like, yeah, it's not taught much about. I'm not saying we have to fix everything at once, but just was wondering your opinion about it. Yeah.
Yeah. And my opinion, just once again, to summarize, is just we need to, as a community, come together around something like binary authorization. I know Google has some good white papers around what they're calling, I guess, Beyond Prod. I think that's what it's called. And Beyond Prod has a bunch of really interesting ideas around how they do Borg authorization and whatnot. And their thing was like, yeah, we have all of this metadata associated with the stuff we're building. And then we have a final process that kind of says, hey, great, on a regular cadence, I'm essentially renewing that authorization. And if something new comes in, right, I now need to require that thing either be rebuilt based on the new requirement or rescanned based on the new requirement or whatever. And if you can provide me with that sort of attestation, then I'll re-sign it. Otherwise, you know, in a week or two, you know, you'll no longer be able to run your thing in production.
Thanks for your answer.
Yeah, I think there's also some pretty big open questions around. I think it's actually somewhat of an easier question when you're building all internal closed source stuff, because you can sort of run your own, you know, SBOM server with all the stuff that you need in, you know, with all the stuff you need in there. But if you start to pull in, obviously, stuff from open source, you know, you're going to want those open source providers to also provide SBOMs as well. And I know that's a big question, is like, hey, whose responsibility is it to distribute those SBOMs? And how deep does it go? Do we go recursively all the way back to the kernel, right? Or even just the compiler of the kernel? You know, do we start to build some of this stuff for hardware and so on? And so I think there's a bunch of big questions about also, you know, when we start to run these things, like, how deep do we go? Or as like some of the other folks who wrote the book, was it the bottom turtle, right? Like, what is that bottom turtle that we say is where we're starting?
Thanks, Mike.
Yeah, no problem.
So we have 5 minutes left. Any other questions to Mike, or any observations or reflections, questions, comments? Okay. Then I just include links to the meeting minutes, the Google document you shared, Mike, as well as the GitHub repo for SSF. I think you recently changed the organization name to BuildSec.
Yep.
Because I was clicking links yesterday and it was just not showing up. I found it.
Yeah, yeah.
So,
sorry about that. Yeah, we just had to move
problem.
because we're moving under OpenSSF, so it's a new org underneath the OpenSSF.
Okay, so I put the link on chat as well. So please, everyone, like if you want to play with this, the instructions are pretty good. Make sample pipeline and runs everything without any effort. You know, it is really nice.
Yep, and in the coming weeks, I'll definitely update this group on we do once the OpenSSF stuff begins rolling. We'll probably start to have our own sort of working group meetings if folks want to actually contribute to the code and build out, whether it's contributing something like, hey, here's maybe how we could hook in something like a Jenkins X, or it could be additional pipelines, additional open source tools that you think would be a good idea to sort of include, whether it's, one of the things that's missing is, for example, is runtime visibility. Could we include something like a Falco or whatever in there? I don't know. But yeah, looking forward to, or hoping that, some folks might be interested in contributing.
Yeah, as I mentioned, like Secure Software Factory and SSF is one of the things we may look as part of our proof of concept we intend to establish under this special interest group. And if that happens, you will probably hear from us and we will probably come back and contribute to the work you are doing there. So thanks again, Mike, for taking time to join our meeting and presentation, the background information and the demo. And I hope you could continue joining to our meetings, because we will be discussing similar topics as you have been summarizing over the past hour. And for all of you, our next meeting will be on 14th of April. And please note the new time, it's 3 p.m. UTC. And we will have Tecton Chains presentation from Priya during that meeting. So until we see each other, I wish all of you have a nice rest of your day, have a nice evening, and have a nice weekend. After tomorrow, it is weekend. So thank you. Talk to you next time.
Thank you.
Bye.
Bye.
Bye.